Now, for continuous data, what is continuous data? That is, you have weighing machine, you have, stopwatches, and you measure the diameter using a vernier caliper, or you use a scale or whatever it is. It's a variable data, right? So what is this measurement system analysis for continuous data that we spoke about? See, whenever you observe a data, I was talking about filling of water in the water bottle or filling of petrol. Now, when you're filling the fuel, whatever that indicator shows, digital indicator shows, if it is 10 liters, it should exactly be 10 liters. How many of you agree with this? Some people might say, if it is more, I'll be happy. But if it is more, the petrol bunk will be at loss, right? Okay, if you pay for 10 liters, that is my question. I'm not saying, okay, if it is 10 liters, it should be exactly 10 liters. I'm saying, if you're paying for 10 liters, you should get 10 liters, right? That is what I'm saying. Now, sometimes what happens, the observed reading, if the device is not faulty, that is, if there is no measurement error, the flow meter which is used to pump in petrol is calibrated. It's a new one, and it absolutely doesn't have any error. Then variation, sigma squared is variation. This variation due to this measuring equipment is 0. So variation observed is equal to variation actual. Okay, so variation observed is equal to variation, and this is what we want. But unfortunately, in the real world, there is a variation caused by the measuring equipment, the flow meter in case of petrol. All right. So with that, what are these components that is causing this variation? Observed variation, I said, it is actual variation because every part will vary. One chocolate will not have the same weight as other chocolate. If you buy Coke, okay, the quantity of Coke inside, the volume of Coke inside will not be exactly same as the other Coke. So there will be a variation, actual variation from one Coke container to the other Coke, one bottle to the other, okay, one cookie to the other. This is called part-to-part variation. But there is also, when you're checking it, there might be a measurement variation. And that is why we wrote variation of observed is equal to variation of the actual, which is part-to-part variation, and variation due to measurement error. And this measurement also has two components. The method can create a problem. Just because I don't know how to measure, it can create a problem. That is called variation due to operators. Because if you ask me to measure a piece of cloth, I may not measure as competent as the person who is in the counter. So that is called reproducibility error, operator to part, and things like that. Let's stick with reproducibility. And measurement due to gauges can be due to repeatability, bias, stability, and linearity.